Hello grade 10s. This is your second lesson for the EM spectrum. In the last lesson we introduced the topic and you had a little bit of homework to do, which was to give the uses of where you get gamma rays, x-rays and so on. The memo for this will be uploaded to Teams and you will then use the memo to mark page 1 to 4. Once you've done that, then you're going to do page 5 and page 6 on your own. I'm going to do the first one on page 5 with you and give you a little bit of advice for doing the rest of it, and then you're going to do the rest of it. Once you've done that, then you can use the memo to mark your work. Once you've done that, then you're going to go to the General tab. You're going to go to Teams and Files, EM Spectrum. Then there's the top document here, EM Spectrum Worksheet. You're going to do that for the rest of this lesson. Once you've done that, then you're going to submit it on the Assignments tab in Teams and submit it as an assignment. Your teacher will then check that you've done it and give you a memo for it. She'll also give you a password. The password will be for your next section of work. Sorry, not your next section of work, the next activity that you need to do, which is past papers. So inside the past papers file, go to EM Spectrum, and now there are two past papers. They are password protected. And the reason why we've done that is so that you first have to complete the earlier work and we've got a record that you've done it. We'll then give you the password as feedback in assignments and then you can open these past papers. You're going to go through them, and wherever you see questions relating to electromagnetic radiation or waves, you can do those questions, and that will be for what you'll carry on with next week. Okay, so back to today. Question 6 on page 5 says, calculate the energy of a photon of green light with a frequency of 5,56 times 10 to the 14 hertz. So our formula is E is equal to H times F. Planck's constant 6,6 times 10 to the minus 34. And the frequency is 5,56 times 10 to the 14 hertz. That should give you an answer of 3,67 times 10 to the minus 19. And your units for energy are joules. Alright, calculate the energy of a photon with a wavelength of 6 times 10 to the minus 7 meters. We can use E is equal to H, Planck's constant, times the speed of light divided by the wavelength. Little side note that I didn't mention in yesterday's lesson. Speed of light, the value that we gave you is actually for the speed of light in a vacuum or in air. They're very similar. Like I said, light will travel more slowly in a dense medium such as water or glass or perspex. It would be a bit slower. And the difference between speed of light in air and in a vacuum is very slight, but there is a small difference. Of course, light will travel a little bit faster in a vacuum. But that speed of light is not just for light, it's actually for all electromagnetic radiation. So throughout the EM spectrum, all of these electromagnetic waves, not just light, will travel at that speed. And the value that you use for speed of light in air and a vacuum is 3 times 10 to the power of 8 meters per second. Okay. So Planck's constant, 6,6 times 10 to the minus 34. Speed of light, which, as I've just told you now, is actually the speed of all electromagnetic radiation. The wavelength, 6 times 10 to the minus 7 meters. And you can carry on from there. For this, you need to calculate the wavelength in nanometers of light that has a frequency of 7,5 times 10 to the 14 hertz. Right? So you can use C is equal to frequency times wavelength. You're going to calculate what the wavelength is, and you'll get your answer. If you write your answer in nanometers, so convert your scientific notation value in that you get into nanometers. Remember, nano times 10 to the minus 9. Say, for example, you get a value of 700. That would then mean that you've got red light. So you need to match your answer to one of these values. If you get 500, then obviously it's halfway between blue and green, so you'd say that the color is blue-green. So that's how you approach that question. And you can carry on with the rest of this. If you do have any problems, then just let your teacher know. Thanks, Gr10s.